Hello everyone, I'm recording this video because I wanted to make some comments about practice 6 just to help you with the design. In practice 6 we are going to design a sequential circuit, and this circuit is going to be a counter. If you remember from class, a counter is a kind of sequential circuit that generates a sequence at its output. In class we saw in the last lesson a mod H counter. This counter was a sequential circuit that generates at the output the sequence from 0 to 7. So we are going to have 0, 1, 2, 3 until 7, and we start again. We are going to have one transition with every clock cycle. So we are going to do another counter that generates a different sequence, and this sequence is going to be your ID number. If you are working in pairs, just select the ID number of one of the authors. If you are working on your own, use your ID number. So the output is going to be each digit of your ID number. So imagine that your ID number is this one. We are going to have a 7-segment display, so we are going to generate a 9 after the 9 with the following clock cycle, another 9, a 3, a 2, a 1, another 1, a 2, and a 5. And now we start again with the 9. This is what you have to do in the practice. But we have a slight modification with respect with the mod H circuit that we saw in class. Now we are going to have an input, and this input is going to be used to alternate between two different sequences. If the input is 0, we are going to have our ID number. But if the input is 1, we are going to have our ID number, but with the digit order from the smallest to the largest. So, according to the value of the input, we are going to have this sequence in the 7-segment display, or this sequence. So we are going to come back to the practice document. So you have here the output. The output is going to be a BCD number, a binary digit formed by 4 bits. So what happens if your ID number has fewer digits than 8? Because you are from a road, for example. If your ID number does not have 8 digits, you just fill with zeros in the beginning of the number until you have 8 digits. The design constraints are the following. You can use D or JK by stable, and you have freedom to select the ones you want to work with. So you can use D or JK, you decide. You are going to have a reset signal that is going to be connected in the clear input of the bistable, and you are going to connect the preset input, the PR, to 1, just to make it not influence the system, not affect the operation of the bistables. And obviously you are going to have a clock signal connected to the CK input of the bistable. Before starting, well, here you have the things that you have to fill in the analytical resolution. You have all the steps of the design of a sequential circuit that we saw in class, okay? From the state transition diagram to the excitation tables, in which you are going to extract the logic function for all the inputs or your bistable. If you remember from class, I told you that in the counters it's very important to know in which digit of the sequence we are. So normally we assigned a state to each of the digits of the sequence. Since we have 8 digits, we have here 8 states. And obviously, if we assigned, if the state is the most important thing that we have in the circuit, it's going to be a Moore machine. In a Moore machine, here we are going to have the state and the output for this state. So, for example, if we have state A, B, C until H, we are going to have, imagine that first state, for example A, and the input is my first digit. Now, second state B, the input is going to be my second digit. Third state C, my third digit. No? But in class we saw that the arcs were empty because we didn't have input. Here the arcs are not going to be empty. This is going to happen when the input is 0. So my advice to design the system is to include all the states or the sequence for the input 0, etc., etc., until you have complete your H state for the input 0, completing all the sequence. And once you have this sequence complete, just see what happens if the input changes to 1. Okay, so if the input changes to 1, you have to change the transition to the second sequence. You have to think a little about this. Let me clear the transition diagram state. The transition state diagram. And I'm going to explain about the change of one sequence to the other because it's important. So imagine you are presenting at the 7/7 displays the sequence 0, and you are, for example, presenting the 3. You have the 3 in the 7-segment displays, and now suddenly you have a change of x from 1 to 0, and this change can happen all the time because you have a switch that is going to select between x0 1. So the typical switches that you have in DITs. So this can happen at any time. So you have the 3 in the display and you are in the stream, and suddenly you receive a change from 0 to 1. So you have to keep the order. If you receive a change in the sequence, you are not going to start the second sequence from the beginning. You have to keep the order of the digits in the display. For example, if we are in the 3 here and we change, where is going to be the next digit? The 3 in the second sequence is here. So the next digit should be the 5. So now we are going to have in the next clock cycle here a 5. So you have to keep the order. So for example, if you are in this state in which you have the 3 and you receive a 1, instead of going to the state with the 2, you are going to go to the state with the 5. So if you receive a 1, you are going to go here. So once you have the first sequence with the input 0, check what happens if you receive a 1 for all the state. In fact, when you start designing this, it's quite simple, but it's important that you know that you have to keep the order. It's important as well in these occasions, because imagine now that you are here in this 9. If you change the input, you have to go to suppose that you are in this 9. So the next digit is going to be again a 9, because we are here in this 9. You have to be careful with the digits that are repeated, because we have to correspond the first 9 with the first 9 of the following sequence. So this 9 is correspond with this 9, or for example, this 2 corresponds with the first 2 that we have in the sequence, and this 2 with the second 2. Okay? Because, for example, if the change happens the opposite way, from 1 to 0, and we are here in the second 2, when changing to the first sequence, we have to go to the second 2, and the next digit is going to be 5. Okay, this is important. If we were in the first in the first 2, when counting the sequence, if we are here, if we receive a 0 and we have to change the sequence, we have to go to the first 2 of the other sequence. So the next digit is going to be 1, not 5. Okay, so you have to distinguish the states, even if the output is the same. Okay, as I say, it's easier to see when you start designing the exercise than here with these examples. Just keep it in mind and ask me if you don't see it clear. Well, when you have your circuit with all of these fields, all the tables, you obtain the excitation table for the input of your bistable, and you implement the circuits in this. I'm going to show you my design for my ID number. So I have here my input that is going to change between 0 and 1, the reset that is going to take the system to the initial state that is going to be the first number of the sequence, the clock signal, and well, a constant 1 that I have to use and a constant 0 that I have to use in some part of the circuit. Here I have my outputs. Your outputs are going to be different. The BCD number formed by the output, in my case, in my ID number, the maximum number is 7. So my most significant bit is going to be 0. If you have, for example, 8s or 9s in your ID number, you are going to have here a combinational circuit that is going to be different from 0. In my case, it's 0 because the highest number is 7, that is 1, 1, 1, and this is going to be 0 for all the digits of my ID number. Here I have the bistable. In this example, I have used the bistable. Okay, and you have to be organized when doing the wiring. Otherwise, you can make mistakes. I like to order everything as much as better as possible to make the connection properly. Once you have your BCD number, if you're in your outputs, you are going to use the block, the converter from BCD to 7-segment display that you implement in practice 5. So use the block you implement. This is the block I did. Use your block to translate the BCD output to the 7-segment display. That's the reason you implemented the block, to use it in this practice, even if you didn't know yet. So once you simulate your design, when you start simulate your design, it's not going to work, okay? Because you have to reset the system to make it work. You have the clock, but it's not working. When you press reset, you bring the bistable to the initial state and it starts working. So I press reset and I start having here my ID number. If I change the input, it's going to change in real time and keeping the order the sequence showed at the 7-segment display. So this is all, okay? This is all that you have to do. as usually, if you have doubts when designing the circuits, ask me, send me a message, or we can fix an appointment for a presential tutoring slot. I think that I have finished all the things that I wanted to explain to you. The thing that you have to upload if in this practice is the analytical solution, the DITS file with the name generator, and a capture of the practice. You have to simulate the practice with this kind of simulation that you already connect, and adding this capture into the document and upload in the zip file. And that's all. So just we'll keep in touch and let me know if you have questions. Thank you.